positive charge is electricity. Acha ji. Now we know what electricity is. Can you hear me fine now, or is my voice still breaking? Acha. So now we know what electric current is. In order to know that how this current it flows, we know that we have got charges. There are two types of charges. One, what we call positive charge. The other is what we call the negative charge. Okay. So for objects, we can say that a particular object it is either positively charged or negatively charged. How does an object become positively charged or negatively charged? For chemistry, we take chemistry at school as well, right? Classes for chemistry. ठीक है. For chemistry, you must have studied the chemical reactions, especially the ionic bonds, in which you would have studied that there are certain substances which they acquire charge, a negative charge by gaining electron, or they acquire a positive charge by losing some electron. So, for example, sodium, it occurs as a positively charged ion, and chlorine, it occurs as a negatively charged ion. Acha, this thing is not happening just at the subatomic level, even the ordinary objects around us. So, for example, if I take a balloon and then I rub it on my head for a bit, that balloon it would have acquired, it would have removed some of the electrons from my hair, and it would have acquired some some negative charge. Okay. Then, when I put this balloon near the wall, when I put this balloon near the wall was originally neutral, but now with comparison to this slightly negatively charged balloon, it would be slightly positive compared to this one. Hence, the balloon it would stick on the wall. Okay. The same thing happens when we are combing our hair as well. Sometimes we there is this what we call static current. Electrons they are removed from a particular substance, and that particular substance it would become positively. Acha, there is also a phenomena which is called induction. So what happens is, let's say that you have got two neutrally charged balls. Okay. So there is neutral charge on ball 1 and there is neutral charge on ball 2. Agreed? So if I bring the two balls together, what would happen is that all the positive charge, if I bring the two of them together, all the positive charge, it would accumulate on one end. Positive charged ions move. Acha, the thing is that the electricity that we have, you would study that the current, we would say it is conventional current. Conventional current, what happens is that we say it's the positive charge which is actually moving. So it moves from the positive end of the battery around the circuit towards the negative end. But this was the original erroneous understanding. This was the original erroneous understanding that it is the positive flow, it is the flow of positive charge. But by the time the scientists they realized what mistake they had made, the thing was so widespread across the globe and so much textbooks had been written that it was just a bit too inconvenient to have that all revised. So they just let that be. Actually, what happens is it's not flow of positive charge, it is flow of negative charge. How does a thing acquire positive charge? If something if something has a positive charge, it means it has lost some of the electrons. That is how something becomes positively charged. So again, hmm, Hmm. No, no. Consider the structure. That is what I'm trying to explain you. Whether a thing is positively charged or negatively charged, it is because of flow of electrons. Whether a thing has positive or negative charge. So this is an atom with a proton in the nucleus and a an electron, equal amount of electron. In the normal state, in the ground state, the positive and the negative charges on an atom, they are balanced out, right? How does this atom become positively charged? If the atom loses this electron, it will become positively charged. Okay. Or if this atom gains another electron, it will become negatively charged. So even things which are gaining positive and negative charge, it is only electrons which are flowing. It is flow of electrons which give anything positive or negative charge. Okay. So these two balls that I was talking about, we had them together, and now I bring a positively charged plate over here. Okay. What this positively charged plate would do, it would move all the negative, it would attract all the negative charge that is there. So all the negative charge of the two balls, it would accumulate on this one, and all the positive, it would be repulsed by that plate that I've introduced over here. In fact, let me draw a better drawing. This one is not good. Acha ji, the better drawing. Okay, so you have two globes which are connected to each other. Initially, they were neutrally charged. This is the initial state. Okay, then on these neutrally charged globes which were connected together, bad drawing again. I introduced a positively charged plate over here. So what this plate would do, all the negative charges they would gather on this ball, and all the positive they would gather on this ball, right? So there is no positive charge, so it would mean all the electrons that are freely available on the two balls, all the electrons. Acha, we know there is a thing called conductors and insulators. There are certain materials which are good conductors of electricity, which means that electricity can easily flow through them. And there are certain materials which are bad conductors of electricity, or what we call insulators, so they do not allow the electricity to flow through them. For metals, we know they are good conductors. Agreed? Why are metals good conductors of electricity? Because in metals, the electrons they are delocalized. In metals, electrons they're delocalized. They form a sort of cloud above the around the surface of the metal, and then now this cloud of electrons it would shift in this direction. The cloud of electrons, the electrons that were delocalized in both these metallic balls, they would shift towards the right ball. So if majority of the electrons they are shifting towards the right ball, it would give the right ball a negative charge, right? And the left ball it would have a positive charge. So now if I separate the two balls, first I separate the two balls and then I remove this positive plate that I had. This ball would have acquired the negative charge and this ball would have acquired the positive charge. Okay, this is called electrostatic induction. What is it called? Induction. INDUCTION. ठीक है. अच्छा, one thing I was mentioning that with respect to how easily current it can flow through a material, we have got three types of substances. The first one are called conductors. Conductors are the ones which always, under all circumstances, they allow electricity to smoothly flow through them. Then we have got insulators. So these insulators, they do not allow the electricity to flow through them. And the third type of material that we have got is what we call semiconductors. So semiconductors, they are the materials, all the materials around us, we can categorize them in three categories based on how much current can flow through them. Categories of materials based on how much current can flow through them. There are three categories. Got it? Does your teacher use the book while teaching at school? Take, take. Did you read this chapter of electricity on your own? Okay. Okay, noted. Shall I move ahead? Acha, what are conductors? Conductors are the materials which allow electric current or electric charge to flow through them under most of the circumstances. Okay. Insulators are which do not allow the current to flow through them. Then there are semiconductors. What happens in semiconductors is that under some circumstances they are conductors, and under different circumstances they are insulators. Usually they are insulators, but by doing certain actions, the electronic chips that we have got all in all the devices that we have, mobile phone, washing machines, computer, those chips they consist of semiconductors. Silicon is the material usually used to make those semiconductors. Do you know the Silicon Valley in USA? It's famous for technology, or the technology companies, for example, Facebook, Instagram, everyone, all of them, they have their head offices over there. That Silicon Valley is famous for the technology incubation. It's in the state of California, which is a desert, and desert sand, it has got silicon in abundance. And just a coincidence that silicon is also used as a raw material for semiconductor chips. So that place, it has got technology businesses which are situated over there. Acha. Coming back to semiconductors, the question is, what would be the use of having such a material, semiconductor? I mean, either you would want the current to flow through a material, or you would want not the, or you would want the current not to flow through a material. What would be the use of having a semiconductor? By the way, the semiconductors, if I give you an example, uh, the full detail of how actually a semiconductor works, that is something that you would study in A levels if you study physics. Okay. Right now, I'll give you an example that a semiconductor, it wouldn't conduct the electric current, but if you give it heat, it becomes a conductor. If you literally have a flamethrower on the top of a semiconductor wafer, it would start acting as a conductor. The question is, why would you have such a material? I mean, what would be the use of having such a material? And obviously, there are uses. That is why we use them in chips and everything. No, because the switches, they have a live wire and a neutral wire. So when your switch is turned on, it is giving the live wire connection to the circuit. When it is turned off, it is giving the neutral wire to the circuit. So the use of semiconductors is that it allows you to control the flow of electric current. If you connect them to a power source, then for a conductor it would allow all the current to flow. But with a semiconductor, you can control the amount of current that actually flows. Okay. Acha. Exact principle of how a semiconductor works, I've told you, you would study that in A levels. Acha sir, the next thing besides this type of materials is that the charges that we talked about, that for current we said it is flow of charge. The SI unit of charge is what? No, that is for current. The SI unit for charges is coulombs, denoted by capital C. Okay. Yes, sir. Understood. Acha ji, so the unit of charges is coulombs, and for one electron, if you want to understand that how much charge is there on an electron, for one electron it has a charge equal to 1.602 into 10 to the power minus 19 coulombs. This is the charge on an electron. Got it? On one electron. So if you have just an isolated electron and you try to calculate charge on that, you would have 1.602 into 10 power minus 19 coulombs. Got it, sir? Acha, if you come to page 175 of your book, it gives you the uses. So, for example, we already studied what electrostatic induction is. Here it gives you the use of electrostatic induction. One use is these inkjet printers. What they do is they give this paper a charge opposite to that of the ink in particular patterns in which they want to print the material. So for example, if I give command to the computer that print this thing, let's say something is written on a paper, there is a shape. What it would do is it would create on paper by electrostatic induction negative charge, let's say, okay, in that pattern. And when that paper it goes from above the ink would have positive charge, it would come and stick to the paper on the places on which it was negatively charged. That way it gets printed. Hmm. Acha, I'll draw it for you. Acha, so initially you have blank paper. You have blank paper, and on your computer screen you have letter A, which you want to print on this paper. So what it would do is it would create by electrostatic induction negative charge on the paper in this pattern. Okay, so when this negatively, and when it is exposed to ink, ink would rush in and stick to this paper in such pattern. You could give it positive charge. Obviously, for electrostatic induction, either you'll have to give it positive charge, or even if you keep it neutrally charged with respect to paper, it would be considered positively charged, right? So that is how the inkjet printers they work. The exact principle it's also given in your book in detail. You can read from there as well. Okay. Acha, the next thing, no, not semiconductor. This is an example of electrostatic induction. What is the use of, for example, what we studied over here when we were giving the charge to a particular ball. So this ball, we made it negatively charged. Why would you make a certain substance negatively charged, or why would you on purpose make a substance positively charged? Because it has then got applications, and one of the applications is in the form of inkjet printers. That is where electrostatic induction comes into play. That is the practical application of that. Electrostatic induction is when you convert a negatively charged substance. Electrostatic induction is the phenomena of converting a neutrally charged substance into a charged one. And in bracket you can write positive or negative. You can make the substance positively. You can convert a neutrally charged substance into a positively charged one or a negatively charged one, either of the two. Acha ji. The next thing is that for all the forces that we have, electricity, we would see that electricity, it can create a force. And for all the forces that are out there, forces, they create fields. For example, the types of forces that we you'll study in your syllabus. Previously, you have studied gravitational force. Now we are studying electrical force, and later you would study magnetic force, right? So, what a force does is, these are the three types of forces that you would study in your syllabus. What a force does is it creates a field around it. What is the field? Field is the area in which the effect of the force can be felt. The, the area around a force in which the effect of the force can be felt is called field. Just a second. The area around a force in which the effect of the force can be felt. So we can say that area around a charge in which the effect of the charge can be felt is electric field. Basic definition of field, and now we are giving the specific one for electric field. The area around a charge in which the effect of that charge can be felt is electric field. The area around a charge in which the effect of in which electrical force can be experienced is called electric field. The area around a charge, the area around a charge in which electric force can be felt or experienced is called electric field. Acha ji, the next thing you'll write is that electric field lines flow from the positive end to the negative end. Electric field lines flow from the positive end to the negative end. Your school teacher didn't cover the concepts of fields during the class? जी sir. Acha ji, after that, what are the different ways or different, for example, shapes in which we can have charges? There can be a point charge, a charge in the form of a single particle, right? If there is one such charge, it would have a uniform electric field all around it. A uniform electric field all around it. Gee, this is called a unit charge. We'll study to the, for example, if there is a single unit charge or if there is a charged plate. So if it is positive, the field lines would be flowing out of it, and if it were a negative charge, then the field lines they would be flowing inwards toward it. Hmm. So for positively charged particle, the field lines would be going out of it, and for the negatively charged particle, the field lines would be coming in towards it. Acha ji. Then, sir, what would happen if I've got two similar charges put together? ठीक है? Both of these are unit charges, the positive and the negative. Now I'm giving you the next circumstance in which there are again two charges. In the previous one, these are not related. The two diagrams that I've drawn above, let me in fact separate them so that they do not confuse you. These are separate like this. Okay. Okay. They are in no way connected. Just saying that if you had a single positive charge lying around, what would it look like? If you had a single negative charge lying around, what would it look like? Acha, now we are considering two charges close together, and both of these charges they have what? Positive. We could even for negative it would be true, but they're same. Or let's say they're different. But what would happen if they're different? Let's see. One is positive, the other is negative. The two charges that are here, one is positive, the other is negative. Now, what the field lines would look like? there would be one going from here to here. The one which was supposed to go above will become bent like this. One going here will become bent like this. Perhaps the one which was to go there would be like this, would be like this. And on this direction, it will become like this. Become like this. G, sir. Correctly spotted. Oh, true. It would be the same when we study magnets as well. Maybe we'll have a similar diagram. Acha ji, so this is when oppositely charged particles are brought together. This is what the field lines would look like. When oppositely charged particles are brought together. Take it, ji. Do that. And this next diagram would be for positive and negative plates. Let me know when you've drawn both the diagrams. By the way, they're in your book as well. But still, it's better if you draw them. Hmm. Hmm. For this last one, this is when you have two oppositely charged plates brought together. Hmm. The field lines they go from positive to negative. Yes, sir. Shall you move ahead? Acha ji. Next, let us try to understand what circuits are and what they look like. So, Janabe wala, for circuits, we would say a simple circuit is where you have a battery. A battery is represented by this symbol. The longer line, it shows the positive end. The shorter line, it shows the negative end. Acha ji, in the circuit, you would have either a resistor. A resistor is shown like this, or you would have a bulb like that is also how we show resistors. It's fine. You can use both the symbols. ठीक है जी, either of the two symbols. अच्छा. So this is what a simple circuit it looks like. We can introduce another feature in the circuit, what we call a switch. So if I introduce a switch as well, it would be like this. Here, here, it is like this and this. So right now the switch is open. In this second case, the current it won't be flowing through the circuit. हाँ जी, only when the switch is closed it would flow. Give me a minute. जी sir, noted. These two diagrams. Acha ji. The next thing is that right now in this particular sequence in which we are going, we do not have this description as of now, but we should know that this is what a series circuit looks like. So what a series circuit is that at any point in the circuit, the value of current stays the same. In a series circuit, throughout the circuit, the, the voltage it would change, but the value of current it stays the same. The device which we use to measure the value of current is called ammeter. So if I connect an ammeter over there and an ammeter over here, if this one is showing X amps, this one would also show X amps. It would be the same amount of current. No, ammeter is connected in series. Voltmeter is connected in parallel. ठीक है. अच्छा, then so for parallel, for example, if I draw a voltmeter over here, it would be connected like this. So voltmeters they are connected in parallel and series. The ammeters they are connected in series. Okay. Acha. The other thing is let us try to understand what current is. So for current, G flow of electrons. So if I say there is a flow of 1 ampere current, it would mean there is a flow of 1 coulomb charge per second. If the current flowing through the circuit is 2 amperes, it means it is 2 coulombs per second, per 1 second. No, no, not 1 electron. 1 electron, I told you it has a charge 1.6 into 10 to the power minus 19 minus 19 coulombs. 1.6 into 10 to the power minus 19 coulombs. Okay, so let's see how much electrons. If a current of 1 coulomb is flowing, Let's see how much electrons are flowing. So I say one electron is equal to 1.6 into 10 power minus 19 coulombs. Okay. So if I divide both sides by 1.6 into 10 to the power minus 19 and 1.6 into 10 to the power minus 19. So do on your calculator 1 over bracket 1.6 into 10 to the power minus 19. ठीक है जी. If I do it on the calculator 1.6 10 power minus 19 bracket, it is something like, so on the right hand side I will have 1 coulomb, and on the left hand side it gives me 6.25 into 10 to the power 18 electrons. So these many electrons are there to make up 1 coulomb. Okay. And if a current of 1 ampere is flowing, if a current of 1 ampere is flowing, it means this much number of electrons are flowing per second through the circuit. Got it? Acha. So some typical values of current which are given over here in your book. The small torch lamp that we have, it takes up about 200 milliamperes or zero point 0.2 amperes. The car headlight that we have, it takes about 4 amperes of current. Okay. Similarly, the electric kettle that we have, it uses a lot of electricity. It takes up about 10 amperes of current. Acha. So now we know a few typical values of current, and we know what's the connection between charge and what's the connection of the charge to current. Acha, something I've already told you, that if you have got an electric circuit, conventionally we used to believe that the current it flows from positive end towards the negative end. This is what we call conventional current. Conventional current. And the electric current, G. In the old days, we used to believe that the current it flows from positive to negative end. So if there is a circuit in front of you and you are asked to draw conventional current, or it asks you to draw so for example, it says there is conventional current flowing through it, draw the direction of the current. It would be positive to negative. Okay, ji? And for electric current, we say it flows from negative to positive. All right, sir. Conventional current is simply what we used to believe that this is how current flows. ठीक है जी. Now let's understand the concept of potential difference. अच्छा, for potential difference, there are three similar concepts at your stage. Again, in IGCSE they don't give you the difference, but there is a slight bit of difference in the three things that I'm about to write. One is called potential difference, or what is also referred to as PD. Then there is PD. The second term used is voltage, and the third term used is electromotive force or EMF. Okay. At guess level, you wouldn't be asked tested on the difference of the three. So for you, it's the same. For A levels, you'd study the difference between the three, and at times you'd even get questions on to calculate if this much is the voltage or if this much is PD, what's the EMF, and so on. You'd learn formulas for that later on. Acha, the concept is that you have got a battery. The battery provides the power and it lights up different devices. Okay. The battery gives power and it lights up different devices. The work done per unit charge, the work done per unit charge in moving it across the circuit. In order to move the charge across the circuit, you'll have to do some work on it, right? In order to light this device, you'll have to move the charges across the circuit. In order to move the charges, you have to do some work on them. You'll have to give them some force. So this force that you give them, or this work that you do per unit charge, that is voltage. Okay. So sometimes it's given as work done per unit charge. So total work done over total charge, that would be your EMF, or that would be your voltage. Total work done over total charge. ठीक है जी. How about we keep it till here, and inshallah from the next class we'll see what the series and parallel circuits are, and what's the effect of series and parallel circuits on the values of current and voltage. Okay. Acha ji, we meet again when we meet again on Saturday. नहीं नहीं